Hello and welcome to the video on Chapter 12, Regression Analysis. The purpose of this video is to discuss the application and use of regression analysis for use in BUA 601. So first I want to start out with what you see here in front of you, which is sort of a summary of all the stuff we've done so far, because it is difficult to capture the importance of regression without understanding how we have arrived at the point with which we are. So we started talking about just data and what data is and understanding why we need data and how we will use the data. And then we moved into describing and graphing the data so that we could see what our data is telling us. And then we moved into understanding the importance of it being a normal distribution. And then some of the features, the central location, dispersion. And then we were able to start doing something with comparisons, but not a lot, right? ANOVA has its limits. As we saw in class recently, we learned that ANOVA doesn't allow us to associate various variables together, nor does it allow us to predict into the future. So Chapter 12 is sort of the answer to that. It's the first model that we have that actually enables some sort of forecasting or prediction about what a couple of things together may cause to happen in the future. Regression really is the first tool that we have learned that enables us to predict. But the thing about regression is it's a little bit like a power tool. It's pretty easy to use, but it can be deadly when we get stuff wrong. I love that description because we can take any two things and correlate them. And we can say that this causes that. My favorite correlation is one's success in undergraduate school to get your undergraduate degree is highly correlated with your 50-yard dash time. There's been a lot of studies on this, and it is highly correlated. But it just doesn't make a lot of sense to me that the faster you can run a 50-yard dash, the higher your likelihood is to graduate from undergrad, right? It doesn't make a lot of sense, but they are highly correlated. So just because you have correlation, it does not mean that you have causation, and it doesn't mean that two things go together. And that's why when we went about our research project, we started with studying the theory, studying the ideas. Then we put the ideas together to predict something. So this is a really important piece about regression. We can run correlations all day long, but we have to have the theory, the ideas, to say A is linked to B, or the relationship between A and B is X. So be really careful with your use of regression. Just because things are correlated, it doesn't mean one caused the other. And just because you can do regression, it doesn't necessarily mean that it's going to provide us with useful information. So really, regression is best used properly. And that's easy to say, but a little bit harder to do. So with that, what I want to do is move into you doing an example and teach you how to apply the example and then how to do the mechanics. You will find that the absolute easiest part of this is actually doing the regression, because Excel mostly does it for you. It's much more about understanding when to use regression, what it's useful for, and what exactly it tells us. So the regression model provides sort of a deterministic way to look at the relationship between two things. It's relatively inexact. It always will include an error term, and we will never be able to say that this proves that, because all of what we do with regression analysis in this class is based on a sample. It's all about sampling. So we are asserting educated assertions, but it's still an assertion. It isn't an exact thing. So of course we know regression is best when done properly, but it's also kind of important to understand that anybody can do a regression, but not just anybody can do the thinking that supports a regression. And that's what separates people, one group of people from the other. I know I talk in this class a lot about the importance of numbers, and I talk a lot about understanding what the numbers mean, but I can't really emphasize this point enough. It helps us, regression helps us estimate, but it doesn't prove anything, and it just simply helps us predict relationships between this and that. But if we do it right, and we do the thinking right, and we take the time to understand what we're doing, it really can be the miracle elixir, as they said in this one book I was reading one time. I mean, you got to understand what you're doing. And the textbook, when we go through how to do this stuff, I think it kind of simplifies it, because it assumes that you've got all the data. You have this and that, the X and the Y, you know what all that is. But, as you know from this class, that's hard to figure all that out. So I'm going to take you through how to do it, but I'm also going to try to give you shed some light on the understanding of what it is and why we think this is related to that. So let's start out by understanding that a regression model looks at the relationship between two things, just like I have been saying. If we have a slope, that means that there is a relationship between A and B, or X and Y, or whatever. So think about that for a minute. Always before, in our null hypothesis and our alternatives, we were using mu, or we were using X, or whatever. But now we're looking for B, slope. We want to see that there is a relationship between this and that. And when we have a slope, then that means that there is a relationship. So any number other than 0 is what we're looking for. So here we have a simple linear regression model. It begins with y hat, because that's a predictor. So y hat is predicted to be comprised of beta naught plus beta 1 times x plus your error term. These coefficients of beta naught and beta 1 are unknown, and the parameters that we're trying to work with are going to be estimated. Beta 1 is the slope that we're after, and the amount we expect y hat to change for each 1 unit change in x1. So all that will kind of keep coming up, and you'll understand that as we work through this. So for each 1 unit increase that we add for x1, then we expect the slope, the y hat variable, to change by the slope amount. So here you can see the basic answer to the question that the textbook starts about, and that is the scatter plot of the relationship between debt payments and income. And this is just sort of a superimposed regression model. So here you can see a simple regression model of the problem that the textbook starts out with. And this is the relationship between income and debt payments. And as you can see here, as income goes up, debt payments also go up. And you can see the y hat formula and the r squared, and you can see that there's a pretty strong relationship between income and debt payments. So this is sort of the end result. This is what you kind of end up with. So when we have something that looks like this, we can predict with pretty good assurity that someone's debt payments are going to go up as their income rises. Not all that surprising, but certainly a nice simple model to begin with. Now a couple of details about our graph here, and that is that we notice that we've got a slope of 10.4 with an intercept of 210. So that means that for every 1 unit increase in x, we're going to expect y hat to increase by 10.441 units. Now the y-intercept, of course, is 210. So if x is 0, then we expect this line here to cross the y-axis at 210. So the r squared value suggests that the relationship is, pretty strong. The relationship between the two variables, the attraction, if you will, is quite strong. Notice how these red dots are all kind of clustered around this line in a fashion that would suggest that the relationship is relatively strong. Here we've got our regression output, and I preferred to make my own regression output as opposed to using the books, just because I like the numbers to be with proper decimals and all that stuff. So we already know from what we learned in the ANOVA chapter that we've got a significant something here, right? Because look at our F. Significance is very low, so our chance of an error, of this occurring by error, is very low. We have a huge F value, and it means the same thing as it's meant all along, and the big value means that it's very unlikely that this could have happened by chance. And when we look at our regression output, I mean, it isn't all that surprising, right? That this relationship is indeed a strong one, right? Because we can see from our graph that the little dots are all very closely located to the green line. So this would then suggest that we have a strong relationship between income and debt payment. So now let's go ahead and work an example. So we're going to work this problem right here, number 13. The consumption function is one of the key relationships in economics. It was first developed by John Maynard Keynes, and it expresses consumption as a function of disposable income, right? Disposable income is income after taxes. In the table below, a portion of the U.S. annual consumption and disposable income for the years 1985 to 2006. That's what the data is. And so I pulled the data, this consumption function data, and I'm going to use Excel to estimate the consumption model, the y hat, if you will. And so let's go ahead and pull up the data and take a look at it. So with this, we're going to go into data, and then data analysis, and then we'll go to regression, and we'll highlight then the X and Y range. So in this problem here, it says that it expresses consumption as a function of disposable income, where disposable income is income after taxes. So that would suggest that, of course, disposable income affects consumption. So disposable income would be the X and consumption would be the Y. So we'll highlight the Y first, and then we'll highlight the X. And we will say that we would like our output to be right here on this page. What happened? So we click here at the place where we want our output to come, right here. We'll just leave everything else not marked, although we do need to mark labels. Let's just see what it gives us. So like we usually do, we'll go ahead and adjust all this so we can read it nicely. We need to change this to be a little higher, and then all of this. So we've got some pretty fine numbers here. You can see that we've got an F value of 1,965, so it looks pretty clear that there is a significant relationship here between disposable income and consumption. I mean, not all that surprising, I suppose. These need to be increase the decimal here. Notice how high the R square and adjusted R square and all that stuff. The strength of the relationship is obviously very strong. And again, not all that surprising. Now, this would not be a paper that you could really get past me, because of course, as disposable income increases, consumption also increases. It's not, it's not really a new idea. So let's just go ahead and graph it just so you can see. But I mean, look at this, practically a perfectly linear relationship. Here in the output, we can see that we've got the intercept and the coefficient. So here, let me just fix this here. So here we've got our intercept value right here, and we've got the coefficient for disposable income. So here you can see I've got the graph, it's plotted, and here is my regression output. What's important is knowing that the significance here is basically a zero chance that we've done this wrong when we have an F value that's this high. Other stuff that's important is we know that here that the sum of squares between the values is much higher than within each column of data, so that's why we have such a large F value. There's really no chance that we got this by error, and of course we go back to the idea, the theory. Does disposable income predict one's consumption? Well, yeah, it clearly seems to predict it pretty well. So basically that's what it tells us. So what I'd like you to do then is do the next couple of problems here that allow you to use data. So that would be number 14, 15, 16, 17. So let's just write that in here. So that'd be problems 14, 15, 16, and 17. And also, I'd like very much for you to think about how these things relate to your data. Could you use this for your data analysis? Because it is very often that a regression model could be used. So what I'm going to do next is I'm going to end this video, but I'm going to make another video to show how we might use regression in an actual research model. So I'll probably use the data that we had looked at in class, and I'll show you how it might be useful to use that, to use this method, regression, on that sort of data. So it's important for you to understand that regression is really the first tool that enables us to predict the relationship between two variables. So I hope this is helpful. I'll see you soon.